All right, we're going to go relatively quickly. So let's see. The explanatory variable, carbohydrates consumed per day, response variable, productivity. So, so problem number one, we have this. Is this the same? All right, so problem number one, I think yours matches up with mine, I hope. Which models show a strong relationship between carbs and productivity? So really none of them do. Okay, so the correlation, gotcha, thanks. The correlation for linear, they have negative 0.03. For quadratic, darn hiccups, they have 0.34. And then cubic, they have 0.56. These two right here are more than likely the R squared value that's given, because they don't give you the R value necessarily with cubic and quadratic. So if those weren't R squared, we could figure out the R value by just taking the square root of those decimals. In either case, none of these have a good correlation that's close to positive or negative 1 for the linear, or positive 1 for the others. Which model is the best fit for the data? So cubic is the best fit, even though it's still kind of cruddy at 0.5613. And this shows the random scatter, which is good. Number 3, which model is not a good fit for the data? Both the quadratic and the linear. Even though so the quadratic, you could kind of maybe say it's a little bit better because it's at 0.34 and it shows you a curved shape. It doesn't tell us what the curve is. Okay, so, the quadratic curve shape might be some, curve shape like this, which is not really a quadratic, but it has a curve to it if we draw on a couple more lines. If you have a particular regression model with correlation of 0.00462, has a randomly scattered plot, residual plot, how would you explain the result to someone trying to make sense? So if you had a correlation of 0.004, that's 0.4%, which has zero, really doesn't have any linear relationship. It was basically found one dot that it went through, and nothing else falls into a pattern. Number 4, if you have a particular regression model that correlation of negative 0.9987 and has a residual plot that is clearly curve shape. So that's the big key on this. Number 4, we have a correlation of this. Okay, so that's really good fit of data, but there is a shape that comes with the residual. And remember, my friends, the residual plot, the one that's above and below the x-axis, we don't want any type of shape to it. We want it to just be random scattered. So for number 4, it says we have a model that will make excellent predictions, but there's got to be a better model out there because we have a shape. So there has to be a better model that we're looking for. We don't want that shape on a residual. And then can a scatter plot have a correlation of 0 and randomly scattered residual plot? Yeah, you could have this. You could have something like this, and then it tries and gives you this line of best fit, which gives you an R value of 0. And being that you do have all of these particular distances above and below, etc., we can have a a random scatter of the residual. So the residual, if we were to plot that, it's going to be something like that, where we're not showing necessarily a pattern to it. Okay, so that's the first page. Second page, use the regression model above. It's number 6. So we have kind of a scattering from our data. It looks like something like this. So we do have, looks like to be a parabola that's going to fit. So predict the response variable when the explanatory variable is 20. So if you went to 20 and you came straight up, and then you came straight over to the y, that's going to be about 85. Okay. And then the residual value for point A. So point A, they're calling down here. So the residual of this would be negative. Okay. And it's below our regression model. Okay. So that's what point A would do. Then let's see, approximate the residual value for A. So if we're approximating the residual value of A, I'm looking at whatever this would be and this would be. So I'm looking for this distance. So it's about 25 minus 50, meaning that this is at 25 in the y direction. This is at about 50 in the y direction. So we subtract our data point from our observed. Hey, hey, totally early, easy. It's good to see you. And then which of the points has the smallest residual? Smallest residual is going to be point D. Point D had this little tiny residual here, even though it's negative. Draw in all the residual for all 4 data points. So if we had C up here, there's a residual. We already have the residual for A. We have the residual for D. And then we have point B down here. So you're just drawing in vertical components. Which of the 4 labeled points indicate the largest over prediction? A is going to have the largest prediction. It is the furthest from, it's the furthest from our line of best fit. And then, are there any outliers or influential points on the data set? The answer on this one is no. We don't have, because our shape is relatively like this, our curve is like this, where we have all these values that are kind of scattered around it. There's nothing over here or down here or up here. This would actually be the residual or the influential point, but we don't have any of those. Okay? So, my friends, between today is Friday, yay-ha, and then we have Monday that happens after Sunday. So what I'd like us to work on, and we will go over on Monday, is page 169, 170. So you have the opportunity to work on this. Come let me know if you need extra guidance, help, support. No.